students? I hope that you are good, well, and fine. So far, we have we have reached to this point that here we will be learning about invertible matrices. What do we mean by invertible matrices? This is very important topic in this chapter, matrices. Okay. So far we have built our theory, uh, which helps to give enough information about what do we mean by invertible and how we are going to use this concept of invertible matrices in this whole thing, matrices. Okay, so you will see that why it is very important subtopic of this matrices chapter. Okay, so the outline is like this, that first of all we will be seeing the definition, and then we will be seeing theorems. Okay, and then we will see that this invertible matrix is how very crucial to find inverse, and what do we mean by inverse of a matrix. Okay, clear? Let us move to next. So invertible matrices. So as if you recall invertible functions, when we say invertible function, if you recall from the previous 11th class, invertible functions, invertible functions means if f a to b is a function, okay, a to b is a function, and there exist, this is a symbol for there exist, and there exist say g, another function g from b to a, such that what is happening, the composition which is f of g, giving me what, identity function, okay, giving me what, identity function. Okay, this means what can you say is that whatever the input you give, you will get the same output. Means input, the output will also be the same input. Okay, clear? Or the other way around also, the composition of f with g will also give you the same thing. Okay, so if such thing is happening, then you say that this f, this f is invertible, and your inverse, this we called it as f inverse. F inverse is this g. Okay, f inverse is this g. So invertible means whenever you came across this word in mathematics, invertible, we somewhere will be talking about the inverse of the given thing, inverse. Okay, if you recall, we can only find our inverse of f if it is 1 1 as well as on 2, or in short bijective. Okay, so in matrices also you will have some criteria, that when do we say that your matrix is invertible and what is its inverse. Okay, now we will see the whole concept of invertibility in matrices. So as we saw in function chapter, so first of all, A must be of a square matrix. So first restriction or criteria is this, the A must be of a square matrix of order whatever you want, say M. If there exists another matrix, square matrix, obviously we are talking about square matrices, B with the same order, such that the product of those two matrices, either you do AB or BA, will, the output will be always same, which is identity matrix of order M. Okay, the same order M. Okay, as you saw. So in functions you can see analogies, that in functions we did what, composition. Here we are doing what, the multiplication, and in as the output what we are getting, the identity matrix here, and here what you got, identity function. Okay, identity function. Clear? Okay. So this means what? Then your P is called the inverse of a matrix A and denoted by this thing. So this means A inverse will be B. Okay. In this case, and only in this case, you say that A is said to be invertible. I hope now it is clear what do we mean by invertible. So whenever you have your inverse, then you can say that given thing is invertible. If you find inverse, if you find the inverse, why we are saying the inverse? Because of the uniqueness of the inverse. Okay, clear? I hope the definition is clear. So suppose you are given with any matrix A, and if you are successful to find such B such that AB is equals to BA is equals to identity matrix, then you say that first of all this A is invertible and its inverse is B. Okay, clear? Okay. So let me think an easy example for you. So say A is what? Your identity matrix. Okay. And B is also say your identity matrix. If you product A, if you product A and B, what you will get? I. And if you product BA, what you will get? I. So in this way, you can easily say that A inverse is B and B inverse is A. Okay. Clear? Okay. I hope that it is clear. If you try to multiply, you will get the identity matrix. Okay. Now so far so good. Let us move to next slide. So here another example. A matrix is given 2 3 1 2. B matrix is given 2 minus 3 minus 1 1 2. Okay. Now just multiply AB. What you will get? How you multiply? So this will be multiply this to get the first row first column element. This will be 2 multiplied to 4 and 3 multiply minus 3 minus 1 will be minus 3. So this will be 1. Okay. This will now multiply with this. So 2 minus 6, 6. This will be 0. Now second row. So 1, 2 minus 2, 0. Now minus 3 and 4 will give you 1. So this is what your identity matrix. This is what your identity matrix. Now what about BA? So BA will be, let us see. So 2 minus 3 minus 1 2 and A 2 3 1 2. You will have what? So 2 multiply 2 4. 4 minus 3 will be 1. Okay. And 6 minus 6 will be 0. Minus 2 plus 2 will be 0. Minus 3 plus 4 will be 1. So now you can say AB and BA is equals to I. Okay, please do verify all the criteria, because in the definition we have given that AB and BA both must be equal to identity matrix, not just one part. Okay, not just one part. So we have to verify for this thing also. Okay, clear? So thus then we can say that A inverse is what? B, or B is the inverse of A in this thing. Okay, clear? Okay, let us move to next. Now note, a rectangular matrix does not possess inverse matrix. So as we already said in our definition, we want our matrix to be square, not rectangular. So a rectangular matrix does not possess inverse matrix. Since for the products BA and AB to be defined to be equal, it is necessary that A and B should be square matrix, as say A is of M cross N and B is of say P cross Q. So first of all, if we want AB, this means this and this must be same. Okay, so this means it must be N. Okay, then only you can define this. Okay, now for what? For BA you need NQ M, and this Q and M must be same, so this must be same, so you must define this. Okay, okay, so far so good. Okay, now what? AB will be what? As you can see, AB will be of what order? AB will be of M order square matrix, and BA will be of what? N. Okay, so in both of the cases you will get different matrices, not same. Okay, you will get different matrices. Yes, but you want what? I. So that's why you want both to be equal to I of the same order. So this M and this N also must be same. Okay. Now, so second point, if B is the inverse of A, then A also the inverse of B. Okay. So B is inverse of A. In other means, if you are given with this thing, it is equals to I. This means that A inverse is equals to B, and other way around also, that B inverse is equals to A. Clear? Okay. Let us move to next. Now, this theorem, the uniqueness of inverse, says that whenever inverse exists, it must be unique. Okay, let us see proof. So how we are going to prove it? Quite simple. So let's see a proof. So if you are given a matrix a square matrix of order M, if possible, let B and C be two different, not two different, but two inverses. Okay, we don't know that they are different or not. Okay, but as we discussed, as the theorem says, that uniqueness of inverses, this means we have to show that B and C both must be equal to each other. Okay, since B is the inverse, so I can write this, and C is also the inverse, I can write this. Okay, let start with B. So B, I can write B is equals to BI. I can write I is equals to AC. Yes, I can write I is equals to AC. Now what? By associative law, as you all know that associativity holds here. So this means BAC, I can pair BA, and BA is what? As you can see, BA is also I, so IC, and IC, whenever identity matrix multiply with any matrix, the output will always be that matrix C. So you started from B, you eventually get C. So this means you showed that B is equals to C. So whenever you have matrix, and if a inverse exists, then you will have unique inverse. You will have unique inverse. Okay, simple proof. Okay, let us move to theorem 4. Now theorem 4 says, if A and B are invertible matrices, this means what? That inverse of A exists and inverse of B also exists of the same order, then AB, the product of this and the whole inverse, is equals to this thing. Okay, clear? So we have to prove that AB whole inverse is same as this thing. Okay, let us see proof. So proof is like this, quite simple, as we know from the definition. So AB inverse, okay, we have to find this thing. Okay, so we know that AB, and we know what? That X inverse will give you identity matrix. So this means AB matrix, whatever the matrix is AB, and its inverse will give you identity matrix. That's why we written like this. Okay, okay, clear. Now, in other words, I am doing what? I am multiplying with, as A is invertible matrix, so this means A inverse also exists. Okay, so I am multiplying with A inverse to both sides. A inverse. Okay, in matrices, always keep this point in mind. If you have such sort of thing, and if you are multiplying things like this, you multiply A here at the left hand side. So please keep this point in mind, that whenever or whatever side you chooses to multiply here, please do choose the same side over here. So you also have to multiply at the left to the this y. Okay, if you write this thing, then you must have to write this thing. You cannot write like this. Okay, why? You all know that in matrices the commutativity is not true in general. So that's why if you are multiplying to the left hand side, please do. If you are multiplying to the right hand side, please multiply to the right hand side. You cannot write like if, at this side you are multiplying right hand side, at this side you are multiplying left hand side. Okay, clear? Okay, so this means this. Okay, so far so good. Now this is just what, like this. Now as you know that associativity thing, you know about associativity. So what this say about this thing? So quite simple. So from this associativity, from associativity I can pair these two. Okay, clear? And I know that this A inverse I will be A inverse, because multiplying with identity matrix I'll get the same matrix back, A inverse. So this means this. Clear? And this will be what? As A is an invertible, so this means A inverse is same as A inverse A, which is identity matrix. So identity matrix. So now what it is written over here? So this is just nothing but, as you can also see, that this will be I. B is already there. So I B A B whole inverse is equals to A inverse. This is just B. Now, okay, now B with AB whole inverse thing. Okay, now what I will do? Now the same thing that I will pre-multiply with B inverse this time. So B inverse, I will multiply to the left to, okay, left side. As you can see, left two terms. Okay, left. So B, now pairing with this will give me iota, sorry, not will give me identity matrix like this, and this will be what? This thing. So as you can see also over here, this will be I identity matrix, this. Hence you showed that AB whole inverse is equals to B inverse A inverse. Okay, so whenever you have two product of matrices, and if you want to find the inverse, you can find their inverse by individually finding inverse of first B and then multiplying the with the inverse of A, like this, in this order. Okay, clear? Okay, let us move next. Now, inverse of a matrix using elementary row operations. Okay, row operations. So how? So to find A inverse using elementary row operation, we write, first of all, we start with A is equals to IA. And then we apply sequence of row operations, sequence of row operation on this thing, till we get something like I is equals to BA. Till we get something like I is equals to BA. And this B will be what? Our matrix. This B will be what? Our, sorry, this B will be what? Our inverse of A. Okay, clear? Inverse of A. Okay, I hope that it is clear. So similarly, if we wish to find A inverse using column operation, then we write this thing for column operation. Okay, then we write this thing for column operation and apply the sequence of column operation on this thing till we get I is equals to A. So for rows we write this, for column we will write this thing. Okay, till you get I is equals to A B, till you get I is equals to AB. Okay, clear? Sorry, this is AB, not this. Okay, so the only difference is here we are writing like this IA, here we are writing like this AI. I hope that it is clear. So let us see. So what else? So after applying one or more elementary row, so we mainly focusing on row operations. Okay, after applying on row operation, one or more row operation, if we obtain all zeros in one row of a matrix A on the left hand side, then A inverse does not exist. please keep this point in mind. If you have to find A inverse by this method, A is equals to IA. Okay, and after applying what elementary row operations, and you find out that one of the rows becomes zero, that every entry in that specific row all are zeros, then A inverse does not exist. Okay, A inverse does not exist. Clear? Okay, I hope that it is clear. Now let's see how we are going to find inverse of this. So first of all, how we are going to find A of IA, as we already saw, A of IA in rows operations. So AI, A is equals to IA. Now, what type of thing we want? I is equals to BA thing. We want I is equals to BA thing. So A can be rewritten as like this. Okay. So this is equal to I 0 0 1. Now 3 5 minus 2 4. Okay. Now what? Now we have to change this matrix into identity matrix. So how we are going to change it? Quite simple. So quite simple thing we will do. What we will do? So uh, let me reduce this thing to the simplest form through which you can easily find what the inverse. So how you are going to? So always make your augmented matrix like this. Augmented matrix means whatever the matrix given to you like this, write it like this, and write your identity matrix here. Okay, quite simple. So 3 5 minus 2 4, 3 5 minus 2 4. Okay, now try to make identity here, and using the same operations try to manipulate these entries. Okay, so how? Quite simple, let me write. So first thing you have to do is add. So what means, this is what your row 1, this is what your row 2. So I am changing row 1. Row 1, this thing suggests that we are doing what? Change in row 1. Okay, so row 1. Okay, row 1. Now in row 1 what we are doing? We are adding row 1 and row 2. So add row 1 and row 2 means R3. So after this what you will get? This thing will happen. Yes, this thing will happen. Okay, I am 1 plus 0, 0 plus 1. Yes, this is what happening. Okay, so this will be what your 1, this will be what your 9, and this will be what your 1, this will also be 1. Simple. Now the second operation what I will be doing, say, now as I have to make here identity, so I make 1 here. Now I want this thing to be 0. Okay, now so R2, the change will be in R2, and the change will be like what? So R2 plus 2R1. This means what? R2 plus 2R1. This means minus 2 plus entry of R1. This means 2 multiply 1, which is this thing. So this means 0. Now 4 plus 2 multiply 9 means 18. Okay, and 18 plus 4 will be 22. 22. Clear? Now this plus 2 times you will get 2. 1 plus 2 times you will get 3. Okay, so far so good. Now the next step is this, that you have to make this entry as 1. Okay, always approach like this. What? Start with this entry, then make 0 here, and then approach to this entry, and then this. Your final stage must be this thing. So you started from this, and now you are at this stage. You want here to be 9, sorry, 1. How you are going to make 1? Quite simple. You will be making equals to 1. How? So this is just nothing. If you try to see what is happening, if you want 1 here, this is 18, 9, 9. What you can say? Yes, this is 9 times 5 is 45. Okay, and this 22 multiply, if you multiply it with 2, you will get 44. So this difference will get you 1. Okay, so this means what will happen. So third thing will be the change in the R2. This means R1. Okay, R1, 5 times R1 minus 2 times R2. So 5 times R1. So first of all, 5 times R1 minus 2 times R2. Okay, clear? So 5, not this. We can do other thing also. So just as we want what? Just 1 here. So what you can do is quite simple. R2 divided by 22. Simple. So 0 divided by 22 still gets 0. 22 divided by this, you will get 0. This will be 1 by 11. This will be 3 by 22. Why I have done this? Because of this, that I want this to be 0. I do not want to be change it. Why? Because I want to make here identity matrix. So this is fixed. This thing is fixed. This only through division I can make it fix. Okay. Now how I can make this 0? Quite simple. Now it is quite simple. Multiply. Now the fourth step will be R1 will be what? R1 minus 9R2. R1 minus 9R2. So 1 minus 0. This 9 minus 9 will give you 0. So 1 minus 9 by 11 and 1 minus 18 by 27 by 22. This thing. Okay, so here you made your identity matrix, and this matrix will be what your inverse, as you can see. So this solve this. This will be 11 minus 9 will be what? 2. So 2 by 11. This will be 2 by 11. This will be what? 22 minus 27. 22 minus 27 will be what? As you can see, minus of 5. Okay, so minus 5. Okay, so let us verify that indeed we are getting the correct answer or not. So A inverse will be 2 by 11, 1 by 11, minus 5 by 22 and 3 by 22. Okay, clear? So 2 by 11, 1 by 11, minus 5 by 22, 3 by 22. Okay, so yes, minus 5 by 22, 3 by 22. Clear? If I made any mistake, please do verify. Okay, so now multiplying A inverse with A will give me what? Identity matrix. So 3 minus 2, 5, 4. Okay, now what? Now just multiply it. Quite simple. So this will be multiplied with this thing. Okay, so you will have 6 by 11 minus 5 by 11. Yes, and this will be plus. Okay, so plus. Now if you add, what you will get, as you can see, okay, what you will get? You will get this will be, as because of the same denominator, you will have 11 by 11. So this means 1. Okay, now multiply with this. You will have 10 by 11 minus what? So 5 multiply 4 by 22. So this will be 2. This will be 11. So 10 by 11. This means 0. Okay, 0. Now for this and this, 3 by 11 minus 3 by 22. Multiply with 2. Yes, this will be cancelled. In denominator, you will have 11. So 3 by 11 minus 3 by 11 will get you 0. Now for this, 5 by 11 plus 12 by 22. So this means multiply. This is just nothing. This thing. And this will be just 2, 11. Now add. This will be 6. So you will have 5 plus 6 divided by 11. This will be 11 by 11. This means 1. So indeed you are getting your identity matrix. So you can say you verified that indeed this is what your inverse. I hope that we have done A inverse A. Now please do verify this thing also. Okay, clear? So let me once again give you steps. Let me once again go through so that you will have idea what we did. So we wrote our A here and we wrote identity matrix here. So A and identity. We want identity to be here and A inverse to be here. So whatever will appear here, you will have your A inverse. You will call it as A inverse. Okay. So you want identity matrix in this position. So how you are going to make it? So obviously you want your form 1 0 0 1. So whenever you want to make identity, always start with this thing. So you want this to be equal to 1. How you can make it 1? Obviously one thing is very clear. Here I have the thing that if you add, you will get 1 here. Yes. The another thing will this another thing also you can do is just divide R1 by 3. If you divide first row by 3, you will get 1 here. You will get 5 by 3. You will get 1 by 3 and you will get 0. You can also do that. No problem. I just want 1 here. Okay. So doing this operation R1 plus R2 in the R1 row, I will get my 1. Or you can also divide the first row with 3. You will get the same thing. Okay. But the apply whatever the operation you want, you will eventually get your answer this A inverse if it exists. Why? Because you all know that inverse will be what? Unique. Okay, clear? Now the second step will be what? Making every entry below this one making 0. So we have, I want to be 0 here, I want 0 to be here. So how I am going to make it? Quite simple. As I have already made 1, then what I will do, as you can see, I will already have -2. So just -2. So this entry plus 2 times of this entry will give me 0 because of -2 plus 2 multiply with 1. You will have your operation like R2 plus 2R1. Okay, means 0. Clear? Now the second step will be making this entry as 1, means this entry as 1. So the appropriate the appropriate operation will be just the division thing. So I divided by 22, you will get 1. Now make this entry as 0. Quite the appropriate operation was R1 in the first row. I am doing what? R1 minus 9 times of R2. You will get 0. So in through all these 4 row operation, I have this matrix, and this matrix I'll be calling it as A inverse. Okay, I hope that you got the idea how we got it here. Okay, so don't worry if you are not getting comfortable with it. We will come back with more examples, with more questions of inverse through row operations, so that from practicing those questions you will have command on this topic of finding inverse using what? Using your row operations or elementary row operations. Okay, I hope that it is clear to you. So don't worry about this concept if you are not comfortable yet. So don't worry, we will be back soon. Okay, with the upcoming sessions of this inverse of a matrix using elementary row operation. Okay, so thank you all. We will be back again. Thank you.